According to ancient Greek historians, the study of geometry originated in ancient Egypt many thousands of years ago. And indeed, the Greek word geometry obviously means earth measurement, and that is also the how geometry supposedly arose is in the context of measuring the land, measuring the earth, and that happened then in ancient Egypt, which I have indicated here in this map. So you can see Egypt is this green stuff, and in particular you see the prominence of the Nile River running through here, being surrounded by this thin, lusciously green strip of land, which is called Egypt proper in the legend down here, and indeed that is the agriculturally viable land where you can have successful farming to sustain life. For the rest, this light green stuff, it's technically part of Egypt, so to speak, but really it's just pretty much desert. That is also indicated here in this satellite photo. So you see, only around the Nile can you actually grow anything, and we shall see that this particular circumstances around this is very important for the how geometry eventually arises in this area. And here's another dramatic indication of this: how the contrast between the fertile area right next to the river and then the dramatic cutoff to the desert. Just the rest is just sand. So like this, and here is the how a later Greek commentator put it, how geometry supposedly arose here in this context. So I'll read a quotation for you. So geometry were first discovered by the Egyptians and originated in the remeasuring of their lands. This was necessary for them because the Nile overflows and obliterates the boundary lines between their properties. And so that is what this picture shows here, that the river has flooded this entire area, and the plots are becoming obliterated by these masses of water standing above. So the flooding of the Nile is absolutely essential for maintaining this thin strip of viable agricultural land there. But then on the other hand, it also means you have to start over with a clean slate every year, restaking your land. So therefore, at this yearly juncture, when all the lands are obliterated, you need a land measurer to come in and redraw the boundaries, or a geometer, as it were, or as the Egyptians called it, rope stretcher. That's the word for geometry. And here you can see some guys running around stretching ropes, to measure fields this way and that. So by the stretching a rope is really a very powerful mathematical tool, simple in its simplicity. Here you see I have a piece of string here, and if I want to make a straight line or a circle, all I need is a piece of string. I just want to make a straight line. I just grab two ends of the string and I just pull it, and there you go. I have a perfectly straight line. Likewise, if I want to make a circle, well, I just have my friend hold on to one end of the string, and I grab the other myself, and I just run around all the way around while keeping the thing as stretched as I can. And voila, I have my circle. So that's a versatile tool, this string. And you can make, for example, a square. Also, I'm not going to spoil the fun here by explaining how exactly you make a square with a piece of string. I mean, you can make an exact square. I don't mean you just wing it, be like, oh well, this looks like 90 degrees to me, is good enough. No, with mathematical precision, in fact, you can make an absolutely perfect square using only a piece of string. Why don't you try it out? Get your own piece of string. Transport yourself back in time to the banks of the Nile River 5,000 years ago and stake out your plot of land over there. That would be that's fun to do. And the construction, eventually a construction of a square using basically steps that can be carried out with the aid of a string was later described obviously in Euclid's Elements, so the famous Greek masterpiece on elementary geometry. So there you can later read precisely this, but it was surely known a long time before it was written up by the Greeks because the Egyptians would have known how to do these kinds of things with a piece of string long before for practical purposes. So that's quite interesting. Here I have another quotation from Proclus again, the same guy I just quoted, and he's saying that the participants in the division of land have sometimes misled their partners in the distribution of land by misusing misrepresenting the the land by using the perimeter as an indicator. So I'm not going to read literally the quotation over there, but here I have drawn for you an illustration that shows what the idea is. So I have drawn two plots of land here. One of them is square in shape, so that's has a perimeter of 400 then, because each side is 100. And then I have drawn another plot over here on the right, which is rectangular though. Nevertheless, it still has 400 perimeter there. So 150 plus 50 plus, goes around as 400. So though they both have the same perimeter, and therefore, in ancient times, you can trick your friends who are mathematically ignorant. You can just fool them and say, "Look, I take this plot on the left over here, because if you walk around it, you will find that it's 400 steps. I go 100, 400 steps. And now you get this plot on the right over here. And why don't you try it out and walk around this plot, and you will find that's also 400 steps. The same, we are all equals here. Well, fair and square. No, of course, that is a trick, because in reality, in fact, what is important for when you are acquiring a field, the important thing obviously is not the perimeter but the area. The area is what's going to determine how many the crop yield is going to be determined by the area, not by the perimeter. So that's obviously the area is greater for the square than the rectangle over here, as you can easily calculate. So therefore, mathematics gave you a leg up in terms of earning potential already in ancient times. There you could just grab for yourself a superior plot of land. So you see here, there's another indication of how important it is to be able to make a perfect square, by the way. And these suckers who don't know how to make a square, they're stuck with these crappy kinds of plots that they will be wondering why I have so much bread and they don't, but it's because they don't know any mathematics, you see. So that's a very we see how mathematical reasoning became central in society in this kind of manner. By the way, a little side note here, in terms of studying this, reading historical accounts of these kinds of ancient events can sometimes be kind of confusing. And here I have the account by Sir Thomas Heath, very famous history of Greek mathematics, a standard work in the field. And he is supposedly paraphrasing the quotation from Proclus that I just showed you on the previous page, where, you can trick your friends by doing such and such, comparing squares to rectangles and so on. But here's how Heath formulates it. So Proclus mentions certain members of communistic societies who cheated their fellow members by giving them land of greater perimeter but less area than the plotters took themselves, so that while they got a reputation for greater honesty, they in fact took more than their share of the produce. Okay, so that's saying pretty much the same thing that I described there on the previous page. This idea of the square and the rectangle and so on, with one exception though. Can you spot it? It's not really it's not really a faithful paraphrase, I would say. It is of course the term communistic, that this is takes place in a communistic society, that the idea of fooling your fellow man in this way is somehow associated with communism. Well, in fact, that there's no basis for that in the quotation by Proclus. So what I showed you on the previous slide is the complete quotation by Proclus. It doesn't say anything else about this subject, and he certainly doesn't say anything about communism in any way, shape, or form. So it doesn't say, these societies were built on the principle that everybody should have equal amounts. However, somebody got a square instead of no, nothing like that. It just says one guy could trick another using this method. That's all. It doesn't say it has nothing to do with communism. So that is just a little side remark for the purposes of historiography, that sometimes you have to be on your guard against where these things are coming from. And indeed, I reproduced the title page of Heath's book here, and not for no without reason, because you can see that he is indeed Sir Thomas Heath, and he has all these titles, all these letters here. He's a knight of the such and such Victorian order, and this and that and the other thing, and various. He has all these fancy titles from the royal titles in awarded by the Queen and so on. So if he certainly is a kind of mainstream establishmentarian Englishman, and furthermore, you see the date of publication, which is 1921. It says right here at the bottom line. So a very crucial juncture, indeed, in history, when you in the context of taking swipes at communists. Obviously, the Russian Revolution, they have taken power. The communists have taken power in Russia at this point, just a few years before. So it's going to be absolutely that context of Heath being a mainstream Englishman in this context is going to be inclined to take swipes at the communists at this point, and so you have to interpret these things in a proper context. In any case, that was just a little fun side remark to give a little also sneak a historiographical lesson as well into the story about the origins of geometry in the banks of the River Nile. Well, in any case, thank you. I hope you enjoyed the story.